Two capacitors A and B are connected in series with a battery as shown in the figure. When the switch S is closed and the two capacitors get fully charged, then so there are two capacitors which are in series. The capacitors are 2 microfarad and one more is a 3 microfarad. It's a 3 microfarad and they are connected to a potential, and that is a 10 volt. Of course, we have a switch in the circuit. The switch is closed. We know switch is closed, charges will flow because they are in series, charges will be same. So one is positive charge and other plate get a negative charge, therefore plus Q and minus Q. Potential divides, let it be V1 as well as V2. And the question says it is the circuit which is given and is connected. And the options are says that two options based on the potential difference, and one option is giving the electrical energy and one more option says the total charge. So D is not right. Reason is charge remains same. And option D says ratio of charges on A and B is 3 to 2. It is not at all possible because those two are in series, charge must be same. Then comes the energy. If you want to find the energy, we should know what is the charge across a capacitor and we should know the capacitance. Anyhow, we know. So we'll just find out the energies, then we'll come back to the potential. And if you want to find a charge Q, Q is equal to, it is a C effective and the potential V. Effective capacitance is given by C1 C2, that is a 2 into 3 micro divided by 5 microfarad into potential is 10. Therefore 5 and 10 means 2. 2 if I multiply it is 12. So 12 microcoulomb. So therefore charge is 12 microcoulomb. So once you know the charge, you can find the potential V1 V2. Therefore V1 is equal to potential across the first capacitor is charge Q divided by capacitance C1. It's a 12 micro divided by 2 micro and that comes to be 6 volt. Similarly, V2 is equal to Q divided by C2. It's a 12 micro divided by, it's a 3 micro and that comes to be 4 volt. So total potential is conserved 10. So here V1 is equal to 6 and V2 is equal to 4. So the options are says about the potential. Potential across A is 6 volt whereas B is a 4 volt. So therefore option B is right. So and C is not right. Reason is ratio of electrical energy stored in A and B are 2:3. We'll just find out the energy. Energy in the first capacitor E1 is equal to half C1 V1 square. It is a half into C1. C1 is equal to, it is 2 micro and V1 is equal to 6 volt. Whereas E2 is equal to half into 3 micro and it's a 4 square. If you find a ratio E1 by E2, that is equal to half cancels, micro cancels, 2 into 6 square divided by 3 into 4 square. So it is a 2 into 36 divided by 3 into 16. So it is a 8 and this is a 12. So therefore 12 and 8, 12 by 8. So 4 3s, 4 2s. So 3:2. Option says a 2:3. It's not right. Therefore only one option is right and that is B.